Nature tells the greatest stories. Joshman, Jehovah's Wisdom in Creations.
For more than a century, scientists have tried to understand one familiar but fascinating question. How does a cat fall and still land on its feet? At first glance, it looks effortless, almost like instinct alone is enough. But when studied closely, it becomes clear that this ability is not simple at all. It is the result of a complete system, built from structure, guided by sensing, controlled by the brain, and executed with precise timing. A 2026 study, led by veterinary physiologist Yasuo Higurashi, helped clarify one of the key pieces of this system. A cat's spine is not equally flexible throughout. The front section, called the thoracic region, is highly flexible and capable of twisting easily. The back section, known as the lumbar region, is more rigid and resists excessive rotation. That difference is not accidental. It allows the cat to divide its body into sections that move in sequence rather than all at once. When a cat begins to fall, everything starts with sensing. Inside the inner ear is a structure called the vestibular system. It detects changes in orientation almost instantly. The moment the cat loses its footing, this system signals that the body is no longer upright. Immediately, the head responds. The cat turns its head toward the ground. At the same time, the eyes focus, locking onto a visual reference point. This is not just about seeing, it is about direction. The eyes and inner ear work together to tell the brain exactly where down is. Once the head aligns, the rest of the body begins to follow. The front half of the body rotates first. Because the thoracic spine is flexible, it can twist quickly and freely. The shoulders and front legs adjust with it, supported by a unique skeletal feature, a free-floating clavicle. Unlike in humans, a cat's collarbone is not rigidly attached, allowing greater range of motion in the shoulders. Then, just moments later, the back half rotates. The lumbar spine, being stiffer, follows with control rather than speed. This delay is important. It creates a sequence, head, front, then back, that allows the entire body to reorient smoothly. This all happens in less than a second, and yet, during this motion, the cat does not push against anything. It works within a principle of physics known as the conservation of angular momentum. By rotating different parts of its body in controlled, opposite directions, the cat can change its orientation without spinning uncontrollably. It is not breaking the laws of physics, it is using them with precision. This ability is often called the writing reflex, but that name barely captures what is really happening. Because behind this reflex is a carefully structured body. A typical cat has about 230 bones, compared to 206 in humans. Its spine alone contains more than 50 vertebrae, connected by elastic discs that allow bending and twisting far beyond human capability. These structures give the cat both flexibility and strength, two qualities that must work together. The tail adds another layer of control. It acts as a stabilizer, helping adjust balance and fine-tune rotation, especially during more complex movements. As the cat continues to fall, another adjustment takes place. It spreads its legs slightly. This increases air resistance, slowing the fall just enough to allow full correction. It is not a dramatic change, but it is enough to make a difference. Interestingly, studies have shown that cats falling from moderate heights may experience fewer injuries than those falling from very short distances. The reason is simple. They have more time to complete this entire sequence and prepare for landing. Preparation for landing is just as important as the rotation itself. As the ground approaches, the cat extends its legs downward. The joints begin to bend. The muscles relax slightly, not in weakness, but in readiness. When impact comes, it is not resisted rigidly, it is absorbed. The flexible limbs act like shock absorbers. The joints bend further, spreading the force across the body. The soft pads on the paws reduce pressure on contact. Instead of a sudden stop, the energy of the fall is redirected through motion. This reduces injury and allows the cat to recover quickly. All of these findings, published in the anatomical record, point to one clear conclusion. This ability is not based on a single feature. It is the result of multiple systems working together. Skeletal design, spinal flexibility, sensory input, neural coordination.
Welcome! Let's learn how to clean your cat. First, brush your cat's fur to remove loose hair. Next, bathe your cat with a gentle shampoo. Your cat is now clean and happy. Cats keep clean by grooming. Let's see how. First, they lick their paws. Then, wipe their face. Next, lick their fur smooth. All clean. This layered view shows how the cat's skeleton, muscles, and nerves work together. As it moves, notice the muscles contracting and the nerves sending complexity. Cats and humans have very different shoulder structures. The cat's rigid structure provides stability for pouncing and climbing. The human's floating structure allows for a wide range of arm motion. Observe the cat's walking motion. The clavicle moves independently, allowing the scapula to glide. This close-up shows the independent rotation of the low-impact movement.
Even the cat's vision plays a role beyond navigation. Cats can see in low light up to 6 to 8 times better than humans. Their eyes are highly sensitive to motion, allowing them to react quickly to changes in their environment. During a fall, this visual sharpness helps them lock onto a target and guide their body accordingly. In daily life, the same ability helps them detect prey or avoid danger, even in near darkness. The brain ties everything together. It receives signals from the inner ear and eyes, processes them almost instantly, and sends instructions through fast neural pathways to the muscles. These signals are not random. They are timed precisely, ensuring that each part of the body moves in the correct order. Head first, then front, then back. All within a fraction of a second. Looking at this system raises important questions. Why is the spine designed with 2 different levels of flexibility instead of one uniform structure? Why does the movement follow a consistent sequence instead of happening randomly? Why is the timing so exact that it matches the short duration of a fall? The answers point to balance. Flexibility alone would lead to uncontrolled motion. Stability alone would prevent movement. But together, they create control. The falling cat shows that movement is most effective when it is guided, when each part plays its role at the right time. Even more striking is this. The cat regains control without any external support. There is nothing to push against, no surface to rely on. And yet, through internal coordination alone, it turns a dangerous fall into a controlled landing. That idea is worth thinking about, because it shows that order can exist even in sudden, unstable situations. That control does not always come from outside. It can come from within a well-designed system. The cat does not hesitate. It does not guess. It responds with a pattern that works every time. And in that response, there is something clear to observe. A body built with structure. A system guided by sensing. A movement controlled by timing. All working together toward a single outcome. Landing right.
This is not random. This is not luck. This is design, a wisdom so deep that every living thing moves with purpose. Jehovah's wisdom is not just seen, it is
This is
experienced.
Joshman. Stories of creation, power, and purpose. Stay strong.